Today I will explain hydrocarbon, three types of hydrocarbon, that is alkane, alkene and alkyne. Alkane is saturated hydrocarbon and its general formula of alkane is, just I am writing it here, just watch, CnH2n plus 2 it is. This is alkane. The formula of alkane is CnH2n plus 2, where n is the number 1, 2, 3, 4, 5, like this. This is the alkane. This is alkane, right? CnH2n plus 2. So the first member is methane. Okay, how to write methane? So put n is equal to 1 and C. Okay, the formula will be CH4. So okay, just I am putting it here and I will show you. So it is C1H2 into 1 plus 2. So that is equal to CH4 it is. So this is methane. The first member of alkane is methane. This is methane C. This is methane. Put 1 C is equal, put N is equal to 1 and we get CH4. So this is the methane, right? And methane, the bond structure formula of methane will be like this. See, the bond structure formula of methane will be like this. It is alkane contains only single bond. There is no double bond in alkane. Okay, this is alkane. This is methane. This is methane containing 4 hydrogen atoms and 1 carbon atoms. Right? This is methane. Now the second member of alkane group is ethane. Second member is ethane. How to write ethane? So it is ethane. The second member is ethane, so it is C2H2 into 2 plus 2. So that is C2H6. C2, it is H6 it is here. This is methane, ethane it is. Okay. So just I am showing you. This is ethane. This is ethane it is. Okay, this is ethane. CH2H6. CH2H6, this is ethane, right? C2H6. C2H6 is ethane. Okay, the third member of alkane group is propane. It is propane. How to write propane? Just see, propane it is. Propane. So it is C3H. It is H8. C3H8. This is propane. This is propane. Okay. The hydrogen atom is double of the carbon atom plus 2. This is propane. It's okay. This is propane. Yeah. So in this way, okay, you can write butane, pentane, hexane, heptane, octane, nonane, decane. In this way. It's okay. I'm just showing you how to write heptane. It's okay. Heptane it is. Heptane. heptane. So heptane contains 7 carbon atom, and 7 to the 14 plus 2, it is 16. This is C7H16. This is heptane. This is heptane. This is heptane. It's okay. Likewise, this is. So in this way we can write this alkane on the basis of Cn or CnH2n plus 2 formula. This is the general formula of alkane in this way. Yeah. Now, this hydrocarbon can have this state chain, branch chain, or a ring chain. Okay, a ring it is here. See how it is here. This I am showing you the carbon atoms. This is a state chain. You can write here now. You can put anywhere. This is C. Number 1 and this number 2. Number 1 is state chain and number 2 is branched chain. It is branched chain. Number 2 is branched chain. We have branches. It can have many branches. One or many branches it can have. This is state chain. This is branch chain. Now I am showing you ring now. Ring. So carbon atoms are also arranged in rings. So it is like this. Here this is closed chain. Ring is the closed chain. It is closed chain. Yeah. This is closed chain. Is it okay? See, this carbon is having closed chain. It is, yes. Now, yes, benzene is a chemistry reagent. Benzene is usually found in chemistry lab of schools and colleges. Benzene, it is a liquid. So what is the formula of benzene? So that I am telling you how to do it. What is the benzene? It is, So this is benzene. Benzene contains 6 carbon atoms and 6 hydrogen atoms arranged in chain. Okay, arranged in it is a ring. It is not chain. It is arranged in ring. Look here. This is carbon atom. It's a double bond, single bond, double bond, single bond. Here again double bond. So double bonds are alternatively. Okay, so this is benzene. Benzene, it is here. It is an organic solvent, you can say, usually found in schools and colleges. It is found in school and colleges, and it is organic solvent. Yeah. Next, it is next I'll tell you about carbon is a very friendly element. Carbon is a very friendly element. It has great affinity for hydrogen, but carbon also forms bonds with other elements such as halogen. Halogen. What is halogen? Halogen is fluorine, chlorine, bromine, and iodine. This all four together is known as halogen. So it carbon also forms a bond with halogens, oxygen, nitrogen and sulfur. So in a hydrocarbon chain, one or more hydrogen can be replaced by these elements such that the valency of carbon remains satisfied. In such compounds, the element replacing hydrogen is referred to as a heteroatom. It is a heteroatom. Okay, heteroatom. These heteroatoms are also present in some group as, okay, just I am going to tell you heteroatoms. Okay, and so so what is heteroatoms? So heteroatoms are those atoms which replace hydrogen atoms from hydrocarbon chain. Okay, it may be a halogen, just I told you halogen. So it is fluorine, chlorine, bromine, iodine, or it may be sulfur, or it may be nitrogen. So like this it is here. So we have to study three heteroatoms. One is chlorine, bromine and oxygen, right? Heteroatoms. So these heteroatoms, okay, so they're also known as functional group. Okay, so when the chlorine is present, it is known as chloro. When chlorine is present in hydrocarbon chain, that is called chloro. Okay, chloromethane, chloroethane, chloropropane, chlorobutane, like this. When bromine is present, it is known as bromomethane, bromoethane, bromopropanes, like this. Okay, and when oxygen has four oxygen is heteroatom, and it's four compounds of oxygens we have to study. One is the alcohol, second is aldehyde, ketone and carboxylic acid. So these alcohol, aldehyde, ketone and carboxylic acid, so they contain oxygen atom. Okay, and what is their formula? Okay, I'm just showing you here now. Okay, chlorine has formula Cl, bromine, bromo is Br, alcohol has OH group is okay, and aldehyde is CHO, and ketone is CO, and carboxylic acid is COOH. It is right. Yeah, just I am showing you. Just watch it like this. Just you can see here now. The first one, this is chlorobromo. Okay, this is Cl. This is the bond. This one line, this one hyphen. This is called the bond. So chloro, bromo, then OH. OH is one bond. Okay, this aldehyde, okay, is linked with one carbon of aldehyde is linked with one hydrogen and one oxygen. Okay, now ketone is linked in ketone, carbon is linked with one oxygen, and in this carboxylic acid, carbon is attached with oxygen and OH group, oxygen and OH group. Okay, so this is about, just you can watch it like this. Is this okay? Yeah, this is so these functional groups we have to study in class 10. Only that much here. So okay, so these heteroatoms and the group containing these confer specific properties to the compound regardless of the length of the and nature of the carbon chain, and hence are called functional group. So okay, these heteroatoms, they give property to the okay, hydrocarbon chain. Okay, hydrocarbon chain may be small or the big one, it doesn't matter, but if they are present, these heteroatoms are present in chain, in hydrocarbon chain, then that will give property to that one. Okay, so the property of this hydrocarbon will be the property of this heteroatom. Is it clear? Yeah. So they are also known as the functional group. So some important functional groups just I have shown you here now. So we have functional group is chlorobromo, and second is alcohol, third is aldehyde, then ketone, then carboxylic acid. So this is okay. And next comes the homologous series. What is homologous series? So now what is homologous series? Okay, homologous series here now look here. This is a series of compounds. Homologous series is a series of compounds in which the same functional group, okay, substitute for hydrogen in a carbon chain, okay, and that is called the homologous series. Correct? So once again here, what is homologous series? So now homologous series is a series of compounds in which the same functional group, for example OH group, alcohol group, so okay, substitute for hydrogen in a carbon chain, okay, in a carbon chain. For example, suppose, just I'm showing you here now, for example, suppose methane. You know, methane has a formula CH4, okay. Now you replace one methane with OH group, so that will form what? CH3OH, okay. This is then C2H6, now replace with one, okay, carbon. Look here, this is how look at this is methane. The first one is methane. Okay, one hydrogen has been removed from methane, and in that place OH, okay, has taken the place of that hydrogen, and that is methyl alcohol. It's okay, methyl alcohol, methyl. Okay, this is methane, therefore it is methyl alcohol. You look at the second one here, C2H6. Now look at one atom of hydrogen, it is become 5 here now, it is replaced with OH group. So okay, so this is ethyl alcohol. It's okay. So this is a homologous series, and the important thing about this homologous series is that the two consecutive, okay, homologous series, they differ by CH2 unit. Okay, this is important. Whatever the series may be, it may be a series of alcohol, it may be a series of alkane, it may be a series of alkene, it may be a series of alkyne, it may be a series of aldehyde, no matter it is now. Okay, so each homologous series, so they differ by, okay, CH2 unit. Okay, CH2, this is, I'm just showing you, so CH2 unit like this, it is here. This is, each one differs by CH2 units like this it is. Each series, homologous series, they differ by, okay, CH2 unit. Correct? Yeah. For example, just you can say here now, ki, you know, methyl alcohol is CH3COH, okay, and ethyl alcohol is C2H5OH, okay. If we'll add, okay, CH2 to this one, okay, look here, look at this is methyl alcohol. If we'll add CH to this one, you will get this one, isn't it? This is a homologous series of alcohol. This is methyl alcohol. If you add CH2 to this methyl alcohol, you will get ethyl alcohol, C2H5OH you will get, right? So this homologous series, they differ by CH2 group, and every hydrocarbon or hydrocarbon has this homologous series. It can be a homologous series of alkane, it can be alkene, alcohol, aldehyde, all this is correct. And one more important thing about this homologous series is that the consecutive homologous series, they differ by mass 14U. Okay, the consecutive members of this homologous series, so they differ by a mass of 14U. Because carbon is 12U and two hydrogens are there, so 12 plus 2, it is 14U. So is right. So homologous series, they differ by CH2 unit and they differ by mass 14 unit, it is right. So every hydrocarbon, whether it is alcohol, aldehyde, alkene, alkyne, so they have this homologous series.